Hello students, today let us discuss factor theorem. Factor theorem. So what is this factor theorem? Okay, for that let us consider, let p of x be a polynomial of degree greater than or equals to 1, of degree greater than or equal to 1, okay, and let a be any real number, let a be any real number, okay, then x minus a is a factor of p of x if p of a is 0, and if p of a is equal to 0 if x minus a is a factor of p of x. Let us start with exercise 2.4. The first problem is, determine which of the following polynomials has x plus 1 a factor. Okay, so in order to conclude that whether it is a factor or not, we have 3 steps. That is, the first one is, we will equate this to 0. We will get the 0 of that. That is, x plus 1 is equal to 0. If you equate, we will get x is equals to minus 1. After that, we have to substitute that value in this p of x. Okay, if the remainder is 0, we conclude that it is a factor. If not, it is not a factor. Okay, so let us start with the first problem. That is, p of x is equals to, given as x cube plus x square plus x plus 1. So our g of x is x plus 1. So what we should do? G of x should be equated to 0. Then it will become x plus 1 is equals to 0. From that, x is equals to minus 1. Okay. So now this x is equals to minus 1. Let us substitute in this. That is p of minus 1. This is equals to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So this will become minus 1 plus 1 plus into minus 1 plus 1. So what we got? Minus 1 plus 1 cancel, minus 1 plus 1 cancel. So we got answer as 0. So therefore, as remainder is equals to 0, therefore x plus 1 is a factor of p of x, that is equals to x cube plus x square plus x plus 1. Okay, now let us see second problem. That is, given as p of x is equals to x power of 4 plus x cube plus x square plus x plus 1, and our g of x is x plus 1, which is equals to 0. Okay, from that what you can get, x is equals to minus 1, right? So let us substitute the value of x is equals to minus 1 in the polynomial. Then we will get minus 1 whole to the power of 4 plus minus 1 whole cube plus minus 1 whole square plus into minus 1 plus 1. Then we get it as minus 1 to the power is a whole number, so it will become as plus 1. Minus 1 power is a odd number, it will become minus 1. Minus 1 power is a whole number, even number, it will become plus 1. Minus 1 plus 1. So minus 1 plus 1, minus 1 plus 1 cancel. We are left out with 1. So as r is equals to 1, which is not equals to 0. So therefore, x plus 1 is not a factor of p of x. Okay, this is how we conclude whether it is a factor or not. The next problem, that is x to the power of 4, the p of x is given as x to the power of 4 plus 3x cube plus 3x square plus x plus 1. So we have to check whether x plus 1 is a factor of this or not. So our g of x is x plus 1. Okay, in order to check, what we will do, g of x will be equated to 0. This implies x plus 1 will be equals to 0. From that, x is equals to minus 1. So let us substitute there. So p of minus 1 is equals to minus 1 whole to the power of 4 plus 3 into minus 1 whole cube plus 3 into minus 1 whole square plus minus 1 plus 1. So this will become minus 1 whole to the power of an even number. So it will become plus 1 plus 3 into minus 1 whole to the power of an odd number minus 1 plus 3 into minus 1 whole to the power of an even number. It will become plus 1 plus into minus 1 plus 1. So this implies 1 minus 3 plus 3 minus 1 plus 1. So plus 3 minus 3 cancel, plus 1 minus 1 cancel. We are left out with 1. So therefore remainder is not equals to 0. So therefore what you can conclude? Therefore x plus 1 is not a factor of, I can write simply as p of x. Okay. Now the fourth bit of this, that is the given p of x is x cube minus x square minus 2 plus root 2 into x plus root 2. Okay, and our g of x is same, that is x plus 1. So we will be equating it to 0. Then this will become x plus 1 is equal 0. From that x will be equals to minus 1. So let us replace with x. Okay, then it will become minus 1 whole cube minus 1 whole square minus 2 plus root 2 into minus 1 plus root 2. Then minus 1 to the power of an odd number. So minus 1 minus 1 to the power of an even number 1. So minus into minus will become plus. Anything into 1 will become the same number. So I am writing it as same plus root 2. This will become minus 1 plus 2 plus root 2 plus root 2. Then it will become minus 1 plus 1 minus 1 will become minus 2 plus 2 plus root 2 will become 2 root 2. So these two gets cancelled. We are left out with 2 root 2, which is not equals to 0. So therefore r is not equals to 0. Hence we can write that x plus 1 is not a factor of p of x. Now let us discuss the second problem of exercise 2.4, that is use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. So here he has given us different p of x values as well as different g of x values. Now we have to verify the factor theorem and check whether they are the factors of the given p of x or not. Okay, so for that first let us consider p of x is already given to us as 2x cube plus x square minus 2x minus 1, and the g of x is x plus 1. So what we should do, we have to equate this g of x value to 0. Then it will become x plus 1 is equals to 0. From that x will be equals to minus 1. We got x value as minus 1. Now this x is equals to minus 1 should be substituted in this p of x. Then it will become p of minus 1 is equals to 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 and minus 1 as it is. So 2 into minus 1 whole cube will become minus 1 plus minus 1 whole square will become 1, minus into minus will become plus, and 2 ones is 2 and minus 1. So it will become 2 into minus 1 is minus 2 plus 1 plus 2 minus 1. Minus 2 plus 2 gets cancelled, plus 1 minus 1 gets cancelled. This will become 0. So therefore p of minus 1 is equals to 0. Therefore remainder has become 0. Hence we can call it as x plus 1 is a factor of p of x, which is equals to 2x cube plus x square minus 2x minus 1. Okay, now the second problem, that is p of x is equals to x cube plus 3x square plus 3x plus 1, and g of x is x plus 2. So first consider p of x is equals to x cube plus 3x square plus 3x plus 1, and g of x as x plus 2. So in order to prove this, we have to consider this g of x is equals to 0. Then it will become x plus 2 will be equal 0. From that x we will get it as minus 2. Okay, now substitute this minus 2 in this p of x. Then it will become p of minus 2 is equals to minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. This will become minus 8 plus 3 fours is 12 plus into minus minus 3 twos is 6 plus 1. So this will become 12 plus 1 is 13, 13 minus 14, which will be equals to minus 1. So therefore r is not equals to 0, as well as it is not getting any 0. So therefore x plus 2 is not a factor of p of x. Now the third bit of this problem, that is, if p of x is equals to x cube minus 4x square plus x plus 6 and g of x is equals to x minus 3. So same way, first we have to equate this g of x to 0, then we will get x minus 3 is equal to 0. From that x will be equals to 3, right? Now we have to substitute this x is equals to 3 in x, that is p of 3 is equals to 3 cube minus 4 into 3 square plus 3 plus 6. It will become 3 cube is 27 minus 3 square is 9, 9 fours is 36 plus 3 plus 6. Then it will become 27 plus 3 is 30, 30 plus 6 is 36. 36 minus 36, which is equals to 0. So what we got here, our remainder is 0. So therefore g of x, that is x minus 3, is a factor of p of x, which is equals to x cube minus 4x square plus x plus 6. Now let us discuss the next problem, that is question number 3. Find the value of k if x minus 1 is a factor of p of x in each of the following case. So he has very clearly given that this x minus 1 is a factor. So if this is a factor, it will be equals to 0. Okay, that means the p of x will be equals to 0. So p of x is equals to x square plus x plus k. Okay, and this g of x is equals to x minus 1, from that is equals to 0, right? This implies x is equals to 1, right? So we are substituting in the place of 1, and he is saying that this is a factor. That's why while substituting I am equating it to 0 plus k is equals to 0. Why I am equating it to 0? Because it is a factor. Factor means already given that it is a factor. So now 1 square is 1 plus k is equals to 0. 1 plus 1 is 2 plus k is equals to 0. K is equals to minus 2. So therefore the value of k is minus 2. Okay. Now let us see one more problem, that is p of x is given as 2x square plus kx plus root 2. Okay. So after this, what is the factor? G of x is a factor, that is x minus 1 is equals to 0. This implies x is equals to 1, right? As this is a factor, we will substitute in the place of 1. That will become 2 into 1 square plus k into 1 plus root 2, and we are simultaneously equating it to 0 because given that this is a factor. Okay, this implies 2 plus k plus root 2 is equals to 0. This implies k is equals to minus root 2 minus 2. Okay, you can stop it here, or also you can write it as k is equals to, you can write this root 2 as root 2 into root 2. Okay, then you will get it as, if you take minus root 2 common, then you will be left with, if you take only root 2 common here, you are left out with root 2 minus you have taken common, so plus 1. Okay, if you check minus 2 into minus into root 2 into root 2, which this will become minus 2. Next plus into minus minus root 2 into 1 root 2. Okay, so therefore the k value here is minus root 2 into root 2 plus 1. Now the next problem, that is p of x is equals to k x square minus root 2x plus 1. And what is the g of x? G of x is x minus 1. So this should be equated to 0. Okay, this will become x is equals to 1. Let us substitute there. Root 2 into 1 plus 1, and also I am equating to 0. Then it will become k minus root 2 plus 1 is equals to 0. From that k will become root 2 minus 1. So here the k value is root 2 minus 1, because minus root 2 if I shift it that side it will become plus root 2, plus 1 if I shift it that side it will become minus 1. And now next bit is p of x is equals to k x square minus 3x plus k. What is g of x here? G of x is x minus 1, which is equals to 0. Then this will become x is equals to 1, right? Now p of 1, which is equals to k into 1 square minus 3 into 1 plus k is equals to 0. Then it will become k minus 3 plus k is equals to 0. K plus k will become 2k is equals to minus 3. I am shifting that side, plus 3. So from that k is equals to 3 divided by 2. So therefore the value of k here is 3 by 2.